Welcome to homework.
We are given a phrase structure grammar. In part A, we're asked to show that the string 111000 belongs to the language generated by this grammar. So it'll suffice to give a derivation of this string. Now, an easy way to obtain this derivation is start out with S. This is our start symbol. And then from this, we obtain 1S. And from this, we obtain 11S. And from this, we obtain 111S using our productions. And from this, we can obtain 11100A. And from this, we can obtain 111000, replacing A by 0. So it follows that 111000 belongs to the language generated by this grammar. Now, to show that the string 11001 does not belong to the language generated by this grammar, we're actually going to sort of defer to part C for this. So we have that we'll see in part C that the language generated by this grammar is going to be 1 to the 0, 0 to the m, 1 to the n, 0 to the m. Where n is greater than or equal to 0, and m is going to be greater than or equal to 2, or 3 actually. And we see that the string 11001 does not have this form, because 11001 ends with a 1. So it does not have this form, and so it follows that it is not part of the language of this grammar. Now in part C, we're going to prove that this is in fact the language generated by this grammar. So to see why, we have the rules S produces S1, and S also produces 00A. Sorry, this should be S produces 1S. So this string can begin with 0 ones, and we see that we also have, because of s can be replaced by 1s, string can begin with any sequence, a finite sequence of ones. After this, we see that since a can be replaced by 0a, or a can be replaced by 0, so it follows that the string is any sequence of ones followed by and then we have to have, from our first two zeros, when we first move from S to 0, 0, A, 2 zeros followed by, and then we see that with these last two replacements here, these last two productions, we have to include at least one more zero. So followed by at least one more zero, and therefore it follows that the string is any sequence of ones followed by 3 zeros followed by any number of zeros. And as a set, this is the set of all strings 1 to the n, 0 to the m, where n is greater than or equal to 0, and m must be greater than or equal to 3. And this is the language generated by this grammar.